Hi my friends, today we model this part, which is not so complicated, but it has some problems. The name is safety valve body, and you remember this drawing. We model this fork, yes, this one. Now we create this model, the body of the valve, and you can go further to model all the other parts in order to create the assembly. You have all the procedures in my tutorials if you download the file general index table. This part is taken from Timoteo Carasoto drawings, and you can download it by watching the tutorial number 182. This is my drawing, and we start with generating this first volume. Dimensions 35, 2, radius 23, distance of 33, 11, 30 degrees. So we can start. Standard millimeters IPT, sketch, XY plane, and we draw a line, a vertical line, with a length of 54. This is an axis, and we have a distance from this point to this end of 33. We place this on the center point. We make some modifications here, and let me place this to the left. We draw lines. 2 are here, and other lines are on the bottom. I keep pressed the left button, I go up, then again I keep pressed the left button to go somewhere here, again keep pressed the left button to go here. Good. Dimensions, this is 2 millimeters, this is 3. This angle is 30 degrees. This dimension is 11. We move this a little, and also this. We have to dimension this short line, 2 millimeters. We place this point to the center point. The radius is 23. Diameters 35 is this. And 38 this one. And now we have a fully constrained sketch. Finish sketch, revolve. Okay, we go further with creating the other revolution body, which has a position of 30 for this face. The other dimensions are the same with these ones. Let's do this. I use the plane YZ, F7, line of 30 to the left. 30. This is an axis, and I draw a vertical line, horizontal line, and I stop here. Why? Because I project this geometry and I create a new arc this one, which takes dimension from here, which is radius 2. Then I place these 2 points coincident and tangency between these two. This dimensions is 38 like before, and the angle here is 60. Again, we have a fully constrained sketch, but I draw a line to close this volume with a closed contour sketch. You see? Finish sketch, revolve with join, of course. Okay. I made a mistake here. You see, this is not acceptable because this line F7 is not well placed. It must be coincident with the end of the projected arc. Yes, this arc was projected, this arc is tangent with it, and we draw another contour. Finish sketch, and now you see the right situation, smooth and fine. Now I want you to notice that we have two hexagons here and here, but they are seen only here. We don't have dimensions for them, only the diameters of 38. This means that the distance for the key here is 32. We create these two hexagonal features. One is here. Sketch, polygon with 6 sides, and this is the position vertical of these 2 points, and dimension of 32. Finish sketch, extrude. We extrude this external area with cut to the part. Okay. Another problem now is to apply some chamfers. To do this, I use this plane, F7, project. I project this area, which must be construction, and I draw a sloped line, this one, with the angle of 30. This is a common procedure for hexagonal features. 30, and we remember that the dimension is 32, so we apply here 32 divided by 2. Now we are sure that we go to this midpoint. You see the midpoint. When we apply this chamfer, I connect points to have a sure closed area. Then we apply revolve. We select the axis, which is Z. We apply cut and OK. You see how nice is this solution. This is the point for connection between two arcs or curves. This is not an arc, I suppose, an ellipse, maybe. This is a circle. Same here. We select this face, new sketch. We rotate to the right to have the X to the right, and we apply again 6 sides this hexagon. This point is vertical with this one, and the dimension is 32 as previous. 32. Finish sketch, extrude, external, cut to the part. Okay. Then I use this plane again in order to apply that chamfer. Project this, make it construction, then a sloped line, this one, the angle is 30. You have to learn this procedure, and the dimension from here to the center point is half of 32. We draw that two small lines to create a close contour. Finish sketch, revolve, cut. The axis is this one, Y. The axis Y. Okay. Good. Now the threads. You see, all are with the same dimensions. Gas 3/4 of an inch, and millimeters 26.44, all the three. These two are 11, 11, and this is 7. The end is flat. Hole, this face, this is already selected. You have to select a diameter. You have that diameter. This is with end, flat end, full depth, and here is 11, the depth. Okay, here is exactly the same. Hole, face, center, 11, gas 3/4. Okay, here is 7. The depth is 7. Hole, this face, this center, 7 instead of 11, and okay. Now we create the internal void, but we take care with this end. The radius is 20 of that spherical hollow feature. Plane F7, and we draw a circle with the radius 20. Project this geometry, draw a vertical line. This is a vertical line, but it doesn't get this center, you see. This will be the axis. Then I draw a line from this point to here. Trim. All this, this, and this. You see, this line is fully constrained sketch. Finish sketch, revolve with cut. Everything is given, and we have this result. You see? Then we have to create this revolving cut with dimensions radius 3 here and radius 3 as a continuation. Radius 1 is the last. This is not dimensioned here. You see some arcs and so on. I place here a dimension of 26.5, which is near this 26.45, to use the same dimension as this cut. Okay, you see now that we have a dimension and two arcs. Let's create this sketch. This is the plane F7. We project this line and this line. We draw a line which is an arc. Press the left button, go to the left, and now to have a smooth movement, I press the Control key. I free the button, then I keep pressed again. I keep pressed the control key and I go here. Again, I keep pressed and I go to the end of that line. You see these three curves. Then I make equal these two with a radius 3. I place the radius 1 to this and a dimension. You see one dimension needed. A dimension between this connection point and this center point, 26.5 divided by 2. Fully constrained sketch. I connect this with an arc. I have to project this arc in order to use it. You see? Then an arc from this point to this point and over the other one. Another line is this one. These are construction. This is not important. We have a close contour here. Revolve. Inventor knows what is the profile and we select the axis Z with cut. Okay. You see here what is the situation. We focus now on this profile. You see here, which is placed at 3 millimeters from this point. Then we'll use this face to cut the result. The plane is this one. New sketch, F7, project this arc, draw a line from this point to this arc. The line is center line. Then we draw a horizontal between these two, a distance of 3, just 3. Good. And we have a fully constrained sketch. Finish, revolve, and now we create a join, but not, we don't join with this body, but we create a new solid number 2. Now we have solid bodies, only one. Okay, now we have 2 here. Yes, to be sure which is which, I apply properties and red. You see now what we have. Now if you take a look here, you see that there is a sloped line. A detail here shows us that there is a point, this point, and the other end is here. The point is dimensioned 13 with 3. This means that we can draw this line. Let's do this. F7 and we have here a point. Let's see if we need to project something. This sloped line goes here. I place the vertical to be horizontal between these 2 points. Then we take a look to dimensions. We place a point on this line and dimensions for the point 13, as I said, and 3 from this face. 3. Okay. 1 dimension is needed. Let's see what is that dimension. The angle. This means that we don't have a connection here. I place this point at this end. Now we have a fully constrained sketch. I also place a point to the intersection of these 2 lines, this line and this line. Finish sketch. Then I select this plane for a new sketch, F7. We know that here is that point, so we can place a line, a chord of the circle, vertical chord, which is horizontal, of course, and we project that point in our new sketch. You see now yellow, and we place this chord on the point. Finish sketch. You wonder why these 2 sketches. You'll see, my friends, because now I create a new plane based on these 2 lines, this one and this one. 2 concurrent lines define a plane. Then I use this plane to split the red solid. To see what is here, I make not visible, I hide the first solid, visibility. And now we can split this without any problem. Split. What is the tool? This is the tool. What is the solid? Because we have 2 solids, this and the other one. We select this, and the direction is to the left. Okay. I hide everything. 1, 2, 3. Visibility. Then I re-enter this in the game. I place here a radius of 2. You see here radius of 2 between these two. This is applied only to this volume. 2 millimeters is by default, and then combine. What is the base? This is the base. What is the tool bodies? This is the tool body with join. Okay. Very good. We see now some internal void volumes with dimensions 1, 3, again 3. This was used, this 3. 23, 30, 18. About this axis. Okay. We create a new sketch in this plane. F7. We project this line. We make it construction to be sure that it is not useful in our construction, and we draw a line from here to somewhere, then down, left, up, left, not so, this to left here, and back to the vertical. This is placed okay. This is also okay. So we have only dimensions to add, not constraints. 3 is this. We move a little this one. You see I cannot move. Then I place here the dimension of 1, which is already placed. 30 diameter of 30, diameter of 23, and 18. Now we have a fully constrained sketch, so we can apply revolve. Revolve not as a new solid, but as a cut of this solid. Okay, now we have to apply this radius tool. So let's try. I'm not sure that we can do this. I select this edge, fillet. We cannot do this, and the solution is to eliminate this fillet, which was placed here. I delete this without disturbing the rest of the model, and now I apply fillet of 2 here. Okay, then another fillet to these 2 edges. It happens, my friends, it happens. Okay, now we have to create this cut, 26.5 diameter and 2 millimeters width. We select this plane, F7, we draw an axis from the center point to this. I must project this line and to extend this line to this point. Rectangle here, dimensions 2 millimeters, right 2. Okay, I make this as a center line, and the dimension is 26.5. Finish sketch, revolve. Inventor knows what to do here, so we select only cut instead of join. Okay, you see the cut here. Now we place that chamfers of 1 to these 3 edges. Okay, because we have here a mention, undimensioned chamfers are 1 at 45 degrees. I think that's all. Let's see what is the volume. Collapse all children, and I properties, physical, update, copy, close, drawing, double click, and a new value, which is almost the same. We keep this last value. Okay, and we go to the part to apply material, which is steel cast, and the color or the aspect, which is this one. I select some faces to be machined. I keep press the shift button during selections, and I select steel polished. We make the view shaded, and we compare with the original. Let me make also shaded. You see? this was not this hour is not selected to be still polished. Once again, you see, nothing is changed. Okay, that's all for today. Thanks for watching. Bye bye.